In this question it says, consider the reaction below. The reaction begins with only reactants and the concentration of X is initially 0.5 molar and the concentration of Y is initially 0.6 molar. At equilibrium, the concentration of X2Y is 0.084 molar. What is the value of Kc for this reaction? So what is the equilibrium constant for this reaction? Well, we know that Kc equals products over reactants. So in this case, X2Y concentration over concentration of X squared concentration of Y. So we wrote the equilibrium constant expression. The problem is we know the initial concentrations of X and Y. We don't know their equilibrium concentrations. And when we do this, this is where we use what is called an ice table. So this is ice is initial, change, and equilibrium. And what we want to look at is the concentration of X, the concentration of Y, and the concentration of X2Y. So everything that's in the equilibrium constant expression, anything that's aqueous or a gas, we want to consider in our ice table as we're filling this out. So let's fill out what we know. Well, we know the initial concentration of X. X is initially 0.5 molar. So all of these concentrations are going to be in molar, so I'm just going to label them at the top so I don't have to write molar every time. In this case, this is 0.0500. The initial concentration of Y is 0.600. And the initial concentration of X2Y is 0. How do I know that? Because it says the reaction begins with only reactants. So the reaction does not initially have any product in it. So we know that the reaction is initially going to go towards the products because there is no product. Now let's look at the change. Well, one of the changes is easiest to find, so let's find that one first. In this case, we have X2Y. We're given the equilibrium concentration. So there was initially 0, and finally we have 0.084 molar. So we must have added 0.084 to have an equilibrium concentration of 0.084. How about Y? Well, there's a one-to-one stoichiometry between these two things, which means if this gained a concentration of 0.084 molar, this must have lost a concentration of 0.084 molar. And when you take 0.6 minus 0.084, you find that at equilibrium, the concentration of this must be 0.516. So I just basically took this and subtracted that. What about X? It takes two X's to make an X2Y. So to make 0.84 molar of this, we must have used twice as much of this. So basically what we want to do is take 2, subtract 2 times 0.084. Why 2? Because it takes 2 of these to make one of these. Said another way, it takes twice as many of these to make one of these, so we have to subtract twice as much. If we take 0.5 minus 2 times 0.084, we find that at equilibrium, the concentration of X is 0.332. Now, we are going to use ice tables, or similar tables, in essentially the next 3 chapters. So it's very important to become familiar with these, and we'll go through a few examples like this. Now that we know the equilibrium concentrations, we could simply plug in. The equilibrium concentration of X2Y is 0.084. The equilibrium concentration of X is 0.332, and that has to be squared, times the equilibrium constant of Y, which is 0.516. Simply plug this math into your calculator, and you find that Kc value here is 1.5.